Hello, and welcome to TELUS World of Science Edmonton and the Margaret Zeidler Theatre. My name is Trevor Prentice, and I'm excited to share with you my July 21st, 2013 rendition of The Digital Universe. You're currently watching a series of pictures I took of the southern part of the dome during my show. Following this introduction, I will show you these images again at the interval they were actually taken, along with the audio as presented live at the time. Thanks for watching, and I hope you enjoy the show. All right, so someone mentioned that they saw the sun up in the sky, and you might have been thinking of the thing that is no longer up there, but the sun actually is still up there in the sky. Does everyone see it over here? Yeah, all right, so we're looking at the sky as it appeared earlier this morning. And during the show today, we're going to be looking at things all around us. So most of the things will probably be in front of us, but there will be some things we'll have to turn our heads around and take a look behind us as well. So look all around you. Can anyone tell me, where are we right now? Any ideas? Yeah, we're outside the Science Center. You can see this is the main building over here, and we're sitting in the park. What about this? Does anyone know what this is over here? Just yell it out. Oh, I'm not sure if I heard it there. This is actually our observatory. So some of you might not have even known that TELUS World of Science has an observatory. And this is it right here. It's just outside the main building. So if you exit through the front door and turn to your left, you'll find the observatory. And earlier today, we were launching some rockets from the field, kind of where we are sitting right now. And our observatory has a whole bunch of telescopes that you can look at some really cool things through during the day and in the evening. So we'll take a look at some of those a little bit later in the show. Now, there's another thing I want to mention that's really special about this show. I get to live out one of my dreams, and because all of us right now are sitting in a time machine. So I can do some pretty powerful things with this time machine. Who wants to go into the future right now? Okay, let's go into the future. So hold on tight. Actually, it's a pretty smooth ride, so you don't even have to worry about holding on. But let's go into the future. And actually, we're going into the future right now. Does anyone notice anything happening? Yeah, the sun is getting higher and higher in the sky, exactly. And this is something you've probably noticed happening every single day, as long as it's not too cloudy out there. And it's a very important astronomical observation to make. And the sun doesn't normally move this fast, but we're in the time machine, so we're going forward in time much quicker than normal. And on July 21st, which is today, the sun got up to about this high in the sky. And astronomers like to use certain lines and other tools to measure how high things can get in the sky. So I'm going to show you a line here today. This is a line called the meridian. And can anyone tell me about how high did the sun get today? 57 or 58? What? Feet? All right, I think I heard someone say it. Yes, those are degrees. So the entire sky is split into 180 degrees. Starting at 0 right on the horizon, all the way up to 90 at the top of the sky, and then back down behind us, back down to 0 at the other horizon. So it's a very useful line, this meridian, for finding out how high things can get in the sky. So let's continue going through time. And like I said, there are some important astronomical observations you can make during the daytime, like the sun. And you can see the sun through the telescopes at our observatory, as long as you have, well, we have proper filters on those telescopes. So if you have a telescope as well, make sure you have the proper safety filters before looking at the sun. But you can see some other things during the daytime as well. through the telescopes. One of those things is a planet. And does anyone know what's the brightest planet in our sky? Venus, yeah, very good. Oh, I can tell I've got a smart audience today. That's good to see. And so you can actually see, as the sun's starting to get lower and lower, you can see the planet Venus there in the sky. And if we were to take a look at it through a telescope, in fact, let's try doing that right now. You can sometimes see Venus as a circle, and actually it's not always a perfect circle. It's got phases just like the moon. So you might have seen the moon as a little crescent before, and Venus does that too. Right now we've got not a thin crescent of Venus, but a little bit of it's missing there. You can tell this is much more oblong than a regular circle. And of course we can see that during the day. So if you come to our observatory between 1 and 5, you'll be able to see Venus and even some brighter stars. But a lot more really cool stuff is visible at nighttime. So let's see if we can fast forward time a little bit more and take a look at the sky later in the evening. All right, so what do you see up there in the sky now? Stars, yeah, lots of stars. Anything else? What else is up there? The observatory's purple, yeah, so it's gotten a lot darker here in the park, so it's looking a little different now. Anything else? Just stars? Oh, the Big Dipper, yeah, very good. And the Big Dipper is a constellation, or at least part of a constellation, and there's lots of other constellations up there as well that we'll talk about a little bit more. I think I might even see a planet up there in the sky. Now, planets, at nighttime, we can see them much more easily than during the daytime. You don't need a telescope or anything. But they do look very similar to stars. So if we're looking at the stars in the city, which we are right now, we can't quite see all of them. Oh, now look at the planet's actually stuck behind the tree there a little bit. So let's rewind time. All right, now this one is not quite as bright as some of the other planets, so it's a little bit trickier to see there, especially in the city. As I was mentioning, we have a lot of stray light in the city, and it's called light pollution. Things from cars and street lights and houses, and it makes things trickier to see in the sky when you're in the city. But usually the planets are quite bright. So let's take a look at that planet through our telescope. And can anyone tell me what planet that is? Yeah, that's the planet Saturn. Now I'm noticing something a little bit weird here with its rings. I believe that's actually just a glitch in our system. But Saturn is pretty cool, and if you look at it through a telescope, you can see those rings looking very, very cool. And it's probably my second favorite thing to look at through a telescope. There we go, that's a little bit better, a little bit more what Saturn looks like. Now this would be looking at Saturn through a very powerful telescope, but if you come to our observatory, you can see it. You can still see those rings. Maybe it'll be something a little bit more like this. Just a little smaller there. So very, very cool. I highly recommend it if you've never gotten the chance before. And later this evening, we might see something, my first favorite thing to look at through the telescopes at our observatory. But someone mentioned the Big Dipper. And can anyone see the Big Dipper up there? Where is it? Yeah, it's a little trickier to see. So let's fly out to the countryside, and because then we'll be able to see the stars a little bit better. We can get rid of all that light pollution, and Venus is still, we're looking at it through our telescope still. We better make that a little bit back more to normal. And we'll just set the sun a little bit lower now. We'll get a little bit later in the evening, and now we can see the sky in its full glory. A lot of stars up there, and you can see something else probably jumps out at you right away. What else is up there? The moon, yeah. Anything else? Yeah, some sort of weird kind of galaxy-looking thing. And that's actually called the Milky Way. So if anyone has ever seen that before, it's very, very spectacular and looks very cool. Now, in order to see it quite like this, you'd have to be probably in the middle of the desert, hundreds of kilometers from any city with a very dry sky and no clouds. But if you get out to Jasper or Banff or somewhere in between, you can see the Milky Way maybe a little bit more like this if you have really good eyes. And it's still very, very cool to see the real thing. And the Milky Way is a galaxy. It's a very special galaxy because it's the galaxy that we live in. And a galaxy is an object made up of billions and billions of stars, and really that's all it is. So we'll talk a little bit more about galaxies throughout the show, but I wanted to... Oh yes, someone mentioned the moon as well. So now that we're out in the country and we're looking at the sky a little bit later in the evening, right now it's about 10:30 at night, and so the moon rises tonight at 10:30, but it does move around quite a bit. But the moon, as I was going to say, is probably my favorite thing to look at through a small telescope, because even with a small telescope you can zoom in and see a lot of detail on the moon. And now I'm making the moon very, very big today, and if the moon really was this big, we could actually see the shadow of the Earth on it right now, or this evening at 10:30. But of course the moon's not quite this big, so we won't be able to see that. But if you look through a telescope, you can see some of the craters and the big, as they're called, seas. They're not really water, but they're called seas for some reason. And lots of different patterns on the moon. So I would highly recommend coming to our observatory and taking a look at the moon sometime if you've never seen that. Now, I have another question for everyone. You might have noticed the sun has set. In fact, it has just recently set towards this direction, behind everyone, or behind some of you. Can anyone tell me what direction that is? West. Close. You're close. Now, that was a bit of a trick question, I'll admit. No, it's not east. No, you're definitely closer with west. You've probably learned many times that the sun rises in the east and it sets in the west. But that's not quite right, especially given that we live in Edmonton, and Edmonton is pretty far north. So here in Edmonton, the sun actually sets in the northwest in the summer. So we noticed it was quite high at its maximum height during the day. The sun got up to about 57, almost 60 degrees. And that's the highest it ever gets in Edmonton, 60 degrees. And then it sets way over in the northwest, and this is in the summertime. In the winter, the sun rises in the southeast, and it barely gets above the horizon, and then it sets in the southwest, meaning we have much shorter days, and like I said, a much lower sun. So in the middle of the winter, the sun only gets up to about 13 degrees above the horizon, which is pretty crazy. If you go further south, then the sun is much more consistent. It usually rises in the east and sets in the west, but it still varies a little bit. So keep note of where things are located, because everything I'm going to show you during the show today, including the moon, which for some reason has disappeared on us, there we go, is in its actual location. So like I mentioned, we're almost at 11 o'clock this evening. Everything that you see up here will be in its real location in the sky later tonight. And someone mentioned the Big Dipper. So let's talk about the Big Dipper. Now that we've got those directional points, can anyone tell me where it's located? Which direction? West, yeah. Now it's pretty high in the sky, so let's start in the west and we'll go all the way up, and you should be able to see it in this general area of the sky. Does everyone see it yet? A couple of people still don't, so let me point out those stars. There's 7 stars. 1, 2, 3, 4, 5, 6, and 7. And that's the Big Dipper there. And the reason I wanted to start with the Big Dipper is because it's a very, one of the easiest things to find in the sky, and it's visible all year round, as long as the sun is below the horizon and there's not too many clouds up there. So the Big Dipper is a great constellation, or at least part of a constellation, to start with. Does anyone know what constellation the Big Dipper is a part of?
Ursa Major.
All right, good job. It is exactly right. It is Ursa Major. So let's see, oh yes, I forgot to mention, when you're doing astronomy and when you're a really good astronomer, you need to be very good at one particular skill. It's a pretty fun game, actually. Some of you might have played it. Has anyone played Connect the Dots before? Good, all right. So I'm hearing a lot of young voices saying they're excellent astronomers, so that's good to hear. Let's play Connect the Dots right now, and let's connect the dots of the Big Dipper. There they are, right there. And now let's connect the rest of the dots. Well, so when I'm looking for the Ursa Major, I use my imagination. And those of you who are good at connect the dots are probably good at using your imagination as well. So I imagine a great bear up in the sky. And the Big Dipper, this part is maybe like the body of the bear. And we've got a leg coming down this way, another leg over here, and the head of the bear off in this direction. So let's connect a few more of those stars. And let's see if we can find the bear up there. Does anyone see a bear yet? Yeah, no? Okay, well, keep using your imagination. I'm going to point out a few more things, and then we'll see if we can see the bear a little bit later in the show. So the other reason the Big Dipper is a great starting point is because you can use it to find some other constellations. If you connect these two dots and then connect them all the way up to another star that you might see up there, the next kind of brighter star in the line of that, in the path of that line, you'll find the Little Dipper. This is the tail of the Little Dipper here, so you can just barely see it around in that area. Let's see if we can. So let's connect those dots, the dots of the Little Dipper, and see if we can see another bear. Anyone see another bear up there? No? All right, well, use your imagination. Think really, really hard, and let's see if we can make those bears appear for us today. There they are. Good imaginations. I knew you guys could do it. So you're definitely going to be excellent astronomers. So let's say goodbye to those two bears. Now there's another important thing about that star I pointed out. This star up here, the one that we can connect the dots of the Big Dipper all the way to find that star. Anyone know what star that is? Polaris. Yeah, that's the North Star. And I'm going to circle that star so you don't lose track of it. And then we're going to fast forward time again. But this time we're going to do it in a bit of a special way. And everyone imagine you're inside a camera right now and you've left the lens open. And when you leave the lens open of a camera, you can see all the light that comes into the camera. And it sort of just stays there. That's what we're seeing right now. And you'll notice that just like the sun, the stars in the south move across the sky in these great arcs. But in the northern part of the sky, the stars make giant circles, all circling around that one star that we noticed called Polaris. And that's why it's called the North Star, because it's always in the same point in the sky. All the other stars move. Does anyone know why they're moving? Yeah, well, not so much because of the Earth's orbit around the sun, but because of the Earth's rotation. So we're all sitting on the Earth, we're all standing on the Earth, and the Earth is turning underneath us. So as it turns, everything in the sky appears to move, when really we're the ones doing the moving. So that's why the sun and the stars and the moon, you'll notice, all move across the sky like this. Except Polaris, because it happens to be located right above the North Pole. And so it doesn't appear to move from our perspective. Now, the sun also moves, or appears to move, because we're orbiting around the sun. And so sometimes the sun happens to be smack dab in the middle of this part of the sky. And it makes it very difficult to see the stars in this part. But we happen to be in the summer right now, so we can see the stars here. In the wintertime, we see different stars in the southern part of the sky. And there's three stars I want to point out first to you, because these three stars are kind of the brightest ones in the south part of the sky. Does anyone see them here? And what shape do they make when you connect those stars? Yes, of course, a triangle. And this triangle, as I mentioned, is visible in the summer. It's made up of those three stars, Deneb, Vega, and does anyone know the last star? Altair. No, it's not that, no. So connecting these dots, or these stars, we make a great triangle, and as I mentioned, it's visible in the summertime. So what do you think they called this group of stars? Bambi, close. No, they called it the Summer Triangle. So, pretty easy to remember the name of that. And it makes it easy to find three constellations in our sky, because each of those stars is part of its own constellation. And in the top right, we have a constellation called Lyra. And you've got to use your imagination to see what that is. But astronomers long ago thought that looked like a harp. Does anyone see the harp there? A little bit, yeah. And then the one to the left of it is called Cygnus. And what do you think Cygnus looks like? A swan! Wow, what a great imagination. Your imagination is very well in sync with astronomers from hundreds of years ago. Because that's exactly what they saw too, a great swan in the sky. And then what about the lower one, the lower star? This is called Aquila. They imagined it was an eagle. So everyone use your imaginations. Let's see if we can see a harp, a swan, and an eagle. Concentrate really, really hard on those constellations. There they are. Ooh, that's an interesting eagle. You guys have a very creative imaginations. Nice to see. So those are some of the constellations we have in our nighttime sky, especially the constellations you'll see this evening. There's lots more constellations in our sky. There's in fact 88 constellations in the full sky, northern and southern hemisphere. But I don't want to spend too much more time talking about those, because there's all sorts of other really cool things I want to point out in our sky. So one of those things is another galaxy. So we talked a little bit about the Milky Way galaxy, which is our home galaxy, but there's another galaxy up there in the sky that I like to point out because it's kind of it's the biggest real close galaxy to our home, and it's called Andromeda. So I'll point out another constellation really quickly to the east here. This is the Andromeda constellation. And within the Andromeda constellation, there's a galaxy called the Andromeda Galaxy. And this, if you get to a very, very dark sky out in the countryside, you can just barely see it without any telescope or anything else just above. So when you're looking for Andromeda, look for this kind of sideways V shape. And then just above it, you might be able to see that Andromeda Galaxy. Can anyone see that? It looks a little bit. I need to put my glasses on to see it. But it looks kind of like a blurry patch of light. Let's take a look through our binoculars and see if we can have a better view of Andromeda. Oh, no one has binoculars? You didn't bring your binoculars today? Okay, good. So pass them around, and we will take a closer look. No, I'm just joking. We can make that Andromeda Galaxy appear in 1 second, and it'll make it look like we all have binoculars. There it is. So this is kind of more what you might think about if you think of a galaxy, a spiral of billions and billions of stars. And actually, the Andromeda Galaxy has even more stars than the Milky Way. The Milky Way has maybe 400 billion stars, which is nearly inconceivable, that number. But Andromeda has probably about 1 trillion stars. It's very, very big. So we'll get another look at Andromeda. In fact, let's take another quick look at Andromeda from kind of a different viewpoint right away here.
How far away is Andromeda?
Oh, good question. The Andromeda Galaxy is, well, so when astronomers are talking about distances, they use a whole different unit you might not be familiar with because kilometers and millions of kilometers are not big enough. So they use a unit called light years, and the Andromeda Galaxy is about 2.5 million light years away. So if anyone is unfamiliar with a light year, it's basically the distance that light can travel in 1 year. So I'm going to turn my laser pointer on, and let's see how fast it can make it to the other side of the room here. On my mark, get set, go! Okay, so pretty fast. If you wanted to chase a beam of light, you would have to, let's say you were trying to run around the Earth, you would have to run around the Earth 7 times every single second just to keep up with light. So it's very, very fast. So it can obviously go a very, very long distance in a year and even further in 2.5 million years. That's how far Andromeda is. So we'll get another view of that a little bit later in the show. But I want to show you what Andromeda might look like through a bigger telescope, something like maybe the Hubble Space Telescope. Oh, my apologies. This is not Andromeda, is it? No. Okay, but it's really cool nonetheless. This is actually not a galaxy. This is an object in our own galaxy. This is the Orion Nebula. So this is something that's visible in the winter time, and I talk about it usually in my winter show, but since it appeared for us today, let's talk about it right now. A nebula is basically a huge, huge area with different dust and gases in outer space. And you can see something like this even through the telescopes we have here at our observatory. There's nebulas up as well during the summer, but it doesn't quite get dark enough before we close. If you wanted to see a nebula this summer, you'd have to be out at maybe 1 in the morning and probably away from the city lights. But if you come back in the wintertime, you can see this nebula. It won't look quite like this because, again, this is as viewed through the Hubble Space Telescope, which is one of the most powerful telescopes we have. But anyway, we'll see Andromeda again a little bit later in the show. There's a couple more things I want to mention before we move on to the next sort of stage of our time machine slash, I'll give you a bit of a foreshadowing, slash spaceship. There's a couple more things we can see from the surface of the Earth, but they're a little rarer. One of the things, if everyone has a lot of patience, we might have a chance of seeing one today during the show. Anything up there that you notice? Yeah, shooting stars. And these are sometimes called meteors. And like I said, they're pretty rare, but if you get outside of the city, you could see 5 to 10 every hour. And sometimes during certain parts of the year, we have what are called meteor showers. And you can see even more, maybe 1 to 5 meteors every minute. So, but again, you really have to get out of the city to see these, and you need a lot of patience. Just lay down and stare up at the sky, and then you'll get a chance to see a meteor. And basically what they are huge rocks flying around in outer space, and then sometimes these rocks hit the atmosphere of the Earth, they hit the air, and they come towards the Earth, hurtling very, very quickly, and they heat up. And when they heat up, they light on fire, and we see that streak of light through the sky, sometimes called a shooting star or a meteor. And if they're big enough, a piece of the rock might even land on the surface of the Earth. But most of the time, they burn up entirely, and they disappear before they hit the Earth. Now, another thing that's a little bit rarer to find, but this year is one of the best opportunities. We'll have one of the best opportunities. So try and take a look for this right now. You might have to look all around, because this is one that we usually see more to the northern part of the sky. Yeah, the northern lights. Oh, looks like the sun is starting to come up a little bit. So let's rewind time again, and we'll see if we can take a look at those northern lights. It's a little bit darker skies. There they are. So this isn't a particularly powerful display, but we do have another show called Experience the Aurora that is showing this evening at 7 p.m. if you want to take a look at that show. And it has some much better views of the Aurora Borealis. The aurora are something that are caused by the sun, activity on the sun. And if you head out to our observatory, you can see, sometimes you'll see little lines and almost like explosions coming off of the sun. And those are called solar flares. And if a solar flare happens to be pointed towards the Earth, sometimes when it hits the Earth, it creates these northern lights because it's a lot of radiation and particles, and they hit the atmosphere and they light it up, which is really, really cool to see. Has anyone seen the northern lights recently or at all? A couple people, but it sounds like a few people haven't. The reason that I said the northern lights are right now is a great time to see them is because we're at what's called solar maximum. So the sun has these explosions more often every 11 years. And right now we're at the 11th year, and it just happens to be a powerful year. So, well, it's not powerful as far as solar maximums go, but it is still solar maximum. So we can see a lot more northern lights. And living in Edmonton is good because we see them in the north, of course, much better than anywhere else on Earth. So make sure to check out a website called Aurora Watch because they have an alert system and they can alert Edmontonians specifically for when there's aurora up in the sky. So sign up on there and you'll have a much better chance of seeing the aurora. But who wants to take a view of a few more things from outer space? Anyone want to take off and leave the Earth? All right, a couple people. That's enough for me because I want to go up as well. So everyone hold on tight. Let's do a countdown from 5, 4, 3, 2, 1. Blast off. Here we go. It's a very smooth spaceship, so you don't have to worry about the G-forces or anything. But there we are, high above the planet Earth. And we happen to be, I sort of flew us a little bit north so we'd get a better view of the northern lights. So we kind of are over the northern pole there. But let's see if we can fly back around and take another look at North America. So you can see part of North America there, and you can see all that light pollution that I was talking about earlier in the show. Some very bright areas of North America. We're looking at it a little bit upside down. So this is Mexico down here, and I think this is Edmonton right here. So the sun is just about to hit Edmonton and rise for our morning. But let's fly away from the Earth, and let's take a look at a few other things flying around here in outer space. There's one thing that you can also see from the Earth. You might have seen these before. Has anyone ever seen a satellite from the surface of the Earth? No? Yes? A couple people? Well, satellites, they fly around, and these are things that humans have actually sent up into outer space. So you can see a lot of satellites flying around right now, every one of those dots that's moving. And these satellites, when you see them from the surface of the Earth, they just look like bright stars that are moving much more quickly than anything else in the sky. But not as quickly as maybe an airplane or a meteor. And as you can see, there's lots and lots of satellites orbiting around the Earth. And as we fly further away, we'll see some of the ones that are orbiting further from the Earth as well, hopefully. Well, I don't see too many other satellites out there, but there are lots and lots of satellites. Some of them are not easy to see from our vantage point in space right now. So everyone say goodbye to the Earth and the Moon. You can see the Moon flying by there as well. And let's take a look at what else is out in the solar system. So as we fly away, we'll start to get a different view of some of the planets in our solar system. And I heard a few of you wanted to take a look at some of the other planets. Which planets were those again? Mars, Jupiter. Okay, so let's take a closer look. Oh, and Pluto. We'll take a closer look at Mars and Jupiter, since those seem to be the most popular. And then maybe I'll just talk a little bit about Pluto. So starting at the Sun here, we've got, does anyone know what the closest planet is to the Sun? Mercury. I heard a couple people say Mercury. And this is Mercury's orbit here, this line. What comes after Mercury? Venus, of course. And what about after Venus? The Earth. Yes, that's where we've just come from. And what comes after Earth? What's the next planet? Yeah, that's the planet Mars. Sorry for that. We just got to turn our spaceship around and see if we can fly over to Mars and take a closer view of what Mars looks like, since I had that request. Now, Mars is actually a long way. We've got a very powerful spaceship here today. Normally, it would take about 6 months to fly to Mars, but we've done it in just a couple minutes. And there's a really cool view, actually, because you can see one of Mars's polar ice caps. Now, unlike the Earth, Mars's ice caps are actually made of frozen carbon dioxide, which is something that we usually have in our air. There's probably water on Mars's pole, or frozen water on Mars's poles as well, but most of it's made up of carbon dioxide or dry ice. So if anyone saw any of our demos today on the demo stage, you might have seen some dry ice. Now, one of my favorite things about Mars as well is not so much the planet itself, but Mars's moons. It has 2 moons. Let's see if we can find one. And they're not really so much moons as they are asteroids that have been captured by the planet Mars. Let's see if we can fly over to one of them. You see one? Okay, point us towards that moon and we'll see if we can get there. Now, these moons are a little small. Oh, there they are. And sometimes they're very dark. Oh, we almost hit it. So let's fly around to the light side so we can actually find it. So you can see it's very cool. Asteroids are not always spherical like planets. They're sometimes so small that the gravity hasn't allowed them to turn into a perfect ball or a perfect sphere. And Mars's moons are basically just normal asteroids. All right, so let's fly away. Everyone say goodbye to Mars and Deimos, which is Mars's moon that we were looking at. And what comes after Mars? Oh, a little bit far. Jupiter, yes. Jupiter's the next planet, but there's something in between. It's not just empty space. There's something we call the asteroid belt. So there's the asteroid belt there, and I've made all of these asteroids I've made them appear much bigger than they really are. But you can just see how many asteroids there are in the asteroid belt. And these are just the ones we've discovered. There's lots more out there that we haven't even discovered yet. So if you were really flying through the asteroid belt, even with a powerful telescope, you'd have a hard time finding a single one. It wouldn't be like Star Wars, trying to dodge the asteroids. And you'll notice from this view as well, you can see lots of asteroids flying around the planet Earth. And this is a little bit scary in some ways, because if these asteroids were to hit the Earth, they can do a lot of damage. And in fact, they have in the past. You might have heard about the dinosaurs disappearing. Well, we're pretty sure that was because of a large asteroid that hit the Earth. But they're also a little bit exciting because these asteroids have, they're basically like giant balls of platinum and gold and other really fancy and useful metals. Not all of them, but certain asteroids are. And there's some companies recently, one in particular called Planetary Resources, that have just announced the fact that they exist and are planning to mine some of these asteroids. So as they do that, they'll be able to make access to space a lot cheaper, and humans will hopefully be able to go to space and as tourists or to do business, to mine the asteroids. And hopefully this will allow us to do some good things on Earth as well, because we'll just have a lot more access to things like water and platinum group metals that we need to build our technologies. So it's a really exciting time for space development as well. But let's go back to the planets. The next planet, as you mentioned, is the planet Jupiter. So who wants to fly to Jupiter? 3 people. All right, that's enough. It's pretty cool. We'll fly over to Jupiter. So everyone hold on tight. It could be a bit of a rocky maneuver here. And there's the planet Jupiter. Now, Jupiter is the biggest planet in our solar system. And you can often see it from the planet Earth as well. It's the next brightest planet after the planet Venus. But it just happens to be pretty close to the sun right now, so I didn't mention it earlier. And you can see those stripes there. Those are big storms on Jupiter. And Jupiter has a very, very big storm. Oops, a little fast. There it was. I saw it fly by. Let's rewind time. And this storm has been called the Great Red Spot. Can everyone see it there? Oops, let's fly around to the other side. So there it is right there. It's not quite as red anymore. It changes a little bit, but it's a giant hurricane, and it's been spinning and storming for over 100 years, which is quite amazing. Jupiter has lots and lots of moons, so we don't have too much time to talk about all of them today, but I'll show you the orbits of some of Jupiter's moons. You can just see how complicated the Jovian system is. It's really, really cool, though. All right, we're running a little bit short on time today, so let's quickly talk about the rest of the planets, and then we'll fly out beyond our solar system. So past Jupiter, we have the planet, anyone know? Yep, Saturn, of course, and we looked at it earlier. And then what comes after Saturn? Uranus and Neptune, the furthest planet. Oh, no one's going to say, what about Pluto? Ah, yes, you guys are too smart for me. I knew this was a smart audience. Pluto's not considered a planet anymore. Nothing really changed on Pluto, but we started discovering more and more things out in the solar system. Some of them are closer to the sun than Pluto. Some of them are further away. And rather than include all of these objects as full-fledged planets, astronomers decided to just demote Pluto to a dwarf planet. So here are all our dwarf planets there, and you can see quite a wide range of different things. So it's easier to just learn the 8 primary planets and then learn the dwarf planets as a separate group. So everyone say goodbye to our solar system. We're now leaving the solar system. There's a few more things out in this distance, comets and asteroids flying around, and we can maybe see some of them as we fly further and further away. This is where we think comets come from, and it's called the Oort cloud, but a realistic view of the Oort cloud is probably a little bit more like this. So you can't really see them very easily. And now we can start to see some of those stars having a 3D effect, maybe like your screensaver from 1995. And we're flying around in interstellar space right now. And there's some cool things we know about this area of the universe as well. So one of the things we've been discovering more recently, since 1995 and even more recently, we've been taking a closer look at these stars in particular, but all stars really, and we found that there are planets orbiting other stars as well. It's not just the sun. So every single star that I've circled there has a planet orbiting around it. In fact, most of them have more than one planet. And we're discovering more and more of these every week. It's a very exciting time. And as we get a closer view of these planets, we may be able to even find evidence of life on planets around other stars. And if we did find evidence of life, and maybe it was even intelligent life. Now, that's a lot of ifs, but I'm hopeful. The ones inside this sphere, this grid that I've made, would be able to listen to Earth radio. Because a long time ago, back in the early 1900s, we started sending radio waves out into space that are powerful enough to reach other stars and other planets. So if these aliens, if there were aliens there, had powerful enough technologies, they could be listening to our radio from long ago. Some of the closer ones might even get to watch our television. So be careful what you say on your cell phones, because in a few hundred years, even those radio waves might make it out to some of the other planets. As we keep flying further and further away from the sun, we'll start to get a unique view of the Milky Way galaxy. So we're flying very, very far away now. We're flying very, very fast, much, much faster than light itself. And that's because our spaceship is also a time machine, so we can break some of those laws of physics. But now we're getting a very, very good view of the Milky Way galaxy from outside it. And in fact, no one has ever seen this before because no one could get outside the Milky Way galaxy. So we don't really know exactly what it looks like, but we do know where lots of the stars are, and when we put them together in a 3D view like this, we can get an idea of what it looks like. And we know what other galaxies look like the Andromeda Galaxy. So we know the Milky Way is pretty similar, and it has these great spiral arms, and it looks like that. In the center, you can see lots and lots of stars, probably orbiting around a giant black hole. But we live way out in the suburbs on the Orion spiral arm, so we don't have to worry about that too much. Now, what about all these other dots? What's outside the Milky Way galaxy? Any idea? Other galaxies, yeah. Oh, I wanted to mention real quick before we move on to other galaxies. Our galaxy is about 100,000 light years across. So if we really wanted to fly there, and let's say we could fly on the fastest spaceship possible that doesn't utilize time travel, it would take us 100,000 years to get out to where we are. Actually, much more, because we're out beyond the galaxy now. It would take 100,000 years just to get to the edge of the galaxy. So let's talk about some of these other galaxies that are even bigger than the Milky Way and even further away. So every dot you're looking at now, every one of these little dots outside here is a galaxy, itself containing billions and billions of stars, sometimes hundreds of billions or even trillions of stars.
Aren't most of them destroyed by now because of how long it takes for the light to recharge?
Oh, good question. Well, they might not be destroyed. Galaxies have very, very long lifetimes. But that's a good point. It does take a long time for the light from these other galaxies to reach our planet, for us to see them. Millions or even billions of years, depending on how far away they are. Like the Andromeda Galaxy, which is one of the closest galaxies to our home, the light takes 2.5 million years. So we're looking at the galaxy as it appeared 2.5 million years ago. So a lot of change can happen in that amount of time. But on the galactic scale, things take even longer to change. So probably most of the galaxies we're seeing now are still there, even though we're looking at the light from long ago. But there's even more galaxies out in our universe. So let's take a look at some more galaxies. So every single dot up there now, again, is a galaxy. And some of these galaxies are even further away. So a lot of them could have been destroyed or could disappear or could merge with other galaxies in the time that it takes their light to reach the Earth. Do you think these are all the galaxies that we know about? Well, there's a few more out there, actually. So these are about all the galaxies that we know about, that we've actually seen through a telescope and measured where they are in the universe. So we're looking at pretty much the entire known universe right now. You'll notice there's some pretty big gaps here in this area and up in this area. And the reason there's gaps there, the main reason, is because when we look in these directions, when we try to see what's over there, our own galaxy blocks our view. So if we look in one direction, we're looking along the disk of the galaxy towards the center, and we can barely see anything through the center of the galaxy. And even the other way, there's still a lot of stars in the disk of the galaxy blocking our view. So it's pretty tricky to see beyond there. So there probably are galaxies here, we just haven't found them yet. Some new techniques that astronomers are developing will hopefully let us view some of those galaxies. Do you think there's anything beyond this? Well, it's really, really hard to know. But if we point our telescopes, if we have the right type of telescope, and if we point it away from every galaxy, we look at a galaxy and we point it further beyond in the black space between galaxies, we do see something. We see something kind of like this. And this is called the cosmic microwave background radiation. And it's light coming from every direction of the universe. And in this view, it looks a little bit like the shell of the universe. And that's sort of one way to think about it. But I like to think of it more as a picture of what the universe looked like when it was just a baby. Because this light was emitted 13.6 billion years ago. And 13.6 billion years ago, the universe was just a baby. It had just been born. And it was a lot smaller than it is now because the universe is expanding. And it looked very, very different. There weren't stars, there weren't galaxies, there weren't things that we're used to seeing now. And this is kind of what it looked like. So astronomers and cosmologists, as they're called, can learn a lot about what the universe was like when it was very, very young by looking at this cosmic microwave background and by looking at a few other things. So unfortunately, we're out of time for today. In fact, I should have started letting people into the next show by now. So let's fly back really, really quickly, and that way we can all go home this evening. And if you have any other questions, then please stick around, and I'll do my best to answer some of those questions before the next show. So let's see if we can find our home. Does anyone see the Milky Way galaxy yet? No, there's lots of dots there still. This is our local group of galaxies, so this is kind of our local section of the universe. I think I might see the Milky Way now, but we better fly faster than this if we want to get the next show started on time. All right, so there's the Milky Way galaxy. And you'll notice where we live in the Milky Way, way off on one of those spiral arms. We're flying pretty quick now. Hopefully we don't hit another star. And does anyone see the sun yet? The sun's just a normal star like all the other stars, but as we get closer, it'll start to appear a little bigger in our sky. That's exactly there, and a lot of them aren't even little suns. We're losing track here. We almost missed the sun. Let's reorient our spaceship a little bit. The other stars are just like the sun, and actually lots of them are much, much bigger than the sun. But they're so far away, they just look like tiny, tiny dots of light. Now, does anyone see the Earth? I see a few of the planets flying by, but where's our planet? Yeah, there's the sun. It flew by to our left. And I think I can see the Earth there with the moon orbiting around it. There it is. Now, the last thing we have to find is Edmonton. I wouldn't want to drop you guys off at the North Pole. All right, I think that might be Europe. Ooh, lots of satellites still flying around. That's kind of cool. Which would mean South America. There it is, North America. So everyone hold on tight. Let's see if we can land this spaceship. And there we are, back on Earth. Ooh, some aurora still as well. So thank you very much for coming to my show. I hope you enjoyed it, and I hope you learned a little bit about outer space and the universe. If you do have any questions, stick around, and I should be able to answer them. I might even answer a few of them outside the door if we start the next show. So thanks again for coming. Have a great day at TELUS World of Science Edmonton. Thank you.